Okay, good evening once again from my side to all of you, depending on where you are you are listening from. I know some of you might be in the midnight by now, but that's cool. So let's start. Um, is so the last time we met, I don't know how many of you were available or were around. I think that was on Saturday. So Saturday, my um the other guy supposed to take it. The one who has been taking you guys on Saturdays wasn't available, so he asked me to take his Saturday class for him. And then we on Saturday we were able to go through where is it? Yeah, here. So we went through um data types. I don't know how many of you, no data types, sorry, data structures. I don't know how many of you were around on Saturday, by the way. How many of you were around on Saturday?
I'm sorry I was not there, and maybe this is my first time. Just I had internet problem for a long time. Just I'm sorry. I just join you today.
Oh, okay. That's no problem. So I hope you are on the WhatsApp page, because if you're on the WhatsApp page, you would try our best, and then yeah, okay, yeah, waiting for the recording. Yeah, we would put the recording on YouTube for you soon. So yeah. Okay, so that's no problem. So let me just um revise what we learned last week a little bit, and then we go. So we talked
Okay.
about data types, and then we said that data types are just like you have a basket, and then inside this basket you have different baskets that you have different things that you keep in it. So one of the baskets is called vectors, and then this is one dimensional, which one dimensional data type which can only contain one set or one type of data. So if you are keeping numbers in it, you have to keep only numbers in it. We talk about lists, which is also one dimensional. And for lists, what you can do is that you can put different data types into it. So we talked about data types too. If any of you were not there, the recording for that, we've uploaded the recording on the YouTube page, so you can just check the link out on WhatsApp. And then so that is for list. Then matrix is also a data structure, but for that one it's two-dimensional. I remember I told you guys that we say that it is two-dimensional because let me share my whole screen so that you guys can see everything that I am doing, because let me stop sharing this and then share the window. My window, okay, yeah, so share this. Please confirm if you can see my screen. Can you guys see my entire screen?
Yeah, yeah,
Okay, yeah. So
we
so
can see.
great. So I told you guys last time that for matrices we have it is two-dimensional in the sense that we have the columns like this. So this is the column, and then we have rows. So this is for row. So if you have, let's say, one, two, three, and then four, five, and six, these values here are columns. So these are values that represent columns. So maybe column one, column two, and then column three. So that is for this. And then this one here is row one. And then this one here is row 2. So this is what matrix is about. So it's a two-dimensional data structure that is made up of rows and columns. And the most important thing that you need to know about column matrices is that it contains it can only contain one type of data. So you can't have, let's say, you can't say that you probably have maybe here to be maybe a true, which we know that true is a logical data type, and then maybe you can't say that okay, this should be um, a string 6. So if you do this in a matrix, is you are going to get a problem. You are not going to you are not going to get any correct output. So that is what we talked about last time. And then um yeah, back to this place. Sorry. So we also talk about data frames, and then I told you guys that most of the things that we are going to be doing are all going to be mostly data frames. And we even got to know how we can import a data frame, that is like you have a data set, a CSV files that is already available, and you want to read into your environment. How do you go about it? So that is what we treated the last time we met. So we went through vectors, we went through examples of creating a vector, how to create a named vector, and all of those things. Then how to manipulate vectors, we did all of those things the last time. We also got to know that you can order your vectors. You can also sort it out. We I and then I've also been putting some quiz questions in the notebook. Oh wait, let me share this notebook with you guys. I don't know how many of you have access to it, but let me share it with you guys so that you can access it. Okay, let's copy this and then back to this. So um, yeah. Okay. So I have sent the link to the notebook to the chat again. So you can check it out. And you can just follow along, okay? I think if you have if you click on the link that I've shared, you can just follow whatever we are doing here. So that is it. So let's move on from here, and then we talk about lists. We said that for lists you can keep so many things in it. So you can it's just like a meal that you have protein in that in a meal where you have protein, you have drink, you have dessert. All of them come together to form the meal. So um, that is what list is. This is how we can also create a named list. We I also told you guys that we create a list using the list keyword or the list function. So you can have different variables, yeah, values in a list. So that was what we talked about. Then we went to talk about the operations of a list. Like you can create a new list, a new name, and then give it a new value. So this is you appending a new name to a value, a named list. Then you can also access the a list by using this dollar sign, which I also explained to you guys how that works and all of that. Then we talk about some quizzes. We also went to matrix where we said that to create a matrix, you use the matrix keyword. And then matrix can also, you can um, give names to your matrix by using the row name and then the column name. So the row name, we've defined the row names here, and this is a vector. So we talked about vectors already. So you create a vector, then you assign those vectors to then the row name and then the column names. Then we also got to understand the difference between by row and then by and then n row. So n row, this here when we did this, I told you guys that if you do n row is equal to 2, it is going to give you just two rows. And then n col is equal to 3 means that the number of columns is going to be 3. And we also experimented on what will happen if you give if you have values that are more than, for instance, if I multiply, I told you guys that if when you want to get the values in a matrix, multiply the number of columns, the number of rows you define, the number of columns that you define, which is going to give us 6. So it means that this matrix can only contain 6 values. So if you look here, even though we've defined a value from 1 to 9, you can see that it is only containing 6 values from 1 to 6. Why? Because the number of rows and the number of columns is, if you multiply this by this, you are only getting 6. So that is the reason why we are having this. And yeah, before we move on, let me say this, that please, if should in case I am you guys cannot hear me, you can draw my attention so that I don't know if you can. I think if you can call me on WhatsApp or something, or go to WhatsApp and then yeah, just call me. I don't know. I just sent a message. I've sent a message, long ago in the WhatsApp group, so you can just check it out and then call me if I am probably off. Yeah, so that I will not probably be talking to myself. That is what I want to say. So let's move on. Okay, so we talk about this. We also talk about named um, this is an example of a named matrix which we talk about. Then we also talked about how to manipulate a matrix. We also talk about the operations that you can perform on a matrix. So for instance, you can transpose a matrix. You can also use this multiplication. You can also do an element wise mathematics, like you can add values to the elements in a matrix. You can multiply values in a matrix. You can divide values in a matrix. So this is an example of transposing a matrix. And I told you guys, when it comes to transposing, what we mean is that if you have a matrix that is okay, let me clean this. Sorry. So let's clean this. So you have a matrix that is 1, 2, 3, 4, 5, and 6. If you apply the transpose to this matrix, this is now going to turn to 1 and 4, then 2 and 3, then sorry, 2 and 5, so 2 and 5, and then 3 and 6. So this is how we transpose a matrix to this. So that is what we talked about here. So the transpose, the T is for transposing. So that is what we talked about. Then these are some quizzes. Then we also went to data frames. We learned how to create a data frame, and then we also checked on how to um so this is this value here is the name of the column. So you use this and then you use the vectors to assign the values to the names. So this was what we talked about last time. And then where we also talked about how to manipulate data frames and all of those things. So we also look at here operations that we can perform on a data frame. We can do logarithm of the values. You can create new columns and all of those things. So we also saw that you can also do a summarize. I told you guys last time that in Python, that is in pandas, you use data frame dot describe. But here, if you use summary, it's going to give us the length, that is the number of values in that sample, in that column, and then give you the class of it, what mode it is. We talk about mode already and all of those things. Then we go to this place. We can order data frames. We can also do so many things about data frames. So, and then I gave you guys a summary of these. Now, there's things that we can do to each of these data structures and what we cannot do. Can we name them, the common use, and all of this? So that was what we did the last time we met. Please let me know if you guys have any questions on the last time and then what we did last time before we move on to today's lessons. So don't worry if you're not following though, but I would make sure that we upload the videos to the YouTube channel for you guys to get um the recordings at the right time. So let me know if you guys are following still and you have some questions or confusions or anything that you would want to know before we move on.
I think it is okay. You can proceed, and probably if you have a question, we can talk to you at the last or in between. But I think it is very soon now.
Okay, okay, that's great. That's great. Okay, that's perfect. So let's move on then to today's lesson. So today we are looking at conditionals. And then so let's talk about conditionals. Um I think I saw okay, yeah, some message. Um okay, no questions from you. That's great. That's great. Okay, so let's move on. So today what are we looking at? We are looking at conditionals. So, what are conditionals? That is, we want to look at how can we control how our code runs, and then how often do we want it to run? So, for instance, um, you are doing an analysis, and then you want to be able to print out um the values in your column, the number of values in your column. Maybe that fits a particular condition. So how do you go about it? You want maybe you are doing analysis and you want to plot something, or you want to plot maybe ages of the gender of people that are below 25 years. So you have that in your data set. So how do you do that? You use conditionals. And then the first condition that we would be looking at is the if condition. So this is the syntax for um, R. So in R, if conditions are given by you bring the if statement and then you bring your condition and then your condition should be in a bracket. So this curly bracket and then your code goes into the curly bracket. Some yeah, they said curly. Yeah, is it curly or curly? Sorry, it's curly bracket. So your condition, that is the code that you want, what you want to print goes in there. Yeah, sorry about this. I think this was I was using this to explain to someone to explain something to someone asked a question about it last time. Um, so so this is an example. So we have a variable called expression, and then we want to you want the condition. Okay, so let's unpack this code so that we understand what is happening under the hood. So we have a variable called expression. Okay, so this variable is called expression. Now if we should let's so we want to confirm if this variable is less greater than yeah greater than 2. So if you do this, if we should run this, we are going to have true. So it means that this is true, that the expression that we have here is greater than 3. That is the sorry is greater than 2. Sorry. Now, if this condition is true, then you print what is inside here. So that is what we need to know. So if we now come here, so we now know that this condition that is inside the if statement is true, that the expression value is greater than 2. So because of that, if we run this, what will happen is that it is going to print what we asked it to do. So it is printing this for us. Now, what happens if the condition is false? So let's experiment that. Assuming that I put 5 here. Now, we know that expression is 3. So expression is greater than 5. When you run this, what is going to happen is that nothing is going to be printed. Why? Because this condition is false. And since this condition is false, it doesn't know what to do. So because it can only execute this code when the condition that is given to it is true. So therefore, since the condition that is given to it is not true, it is not going to do anything. It's just going to leave the expression out like that. For this, that is the reason why we need to have an if else statement. So what does the if else statement that do? So you have an if condition, and then you have your code, the code A, the code that you want it to run. Then else means that if this condition is not true, the first condition is not true, what should it do? It should now print the next expression for you. So here we have our variable. Let me just do, do this as variable. So variable or val, so that we would it will not be confusing us. So this is also val. So just our variable. So we are saying here that if the variable that the value that we define here is greater than 2, so you should print what?
Two.
High. That is high expression. Else you should print what? A low expression. So let's do that. Now if you run this, we can see that this is telling us that this is what? A high expression. Why? Because the value we have here is greater than 2. Okay, now let's change this to what? To 5 now. If you now change this to 5, you'd see that it is telling us what? The expression is what? So low expression. So this is why we need an else statement when it comes to just using an if statement. Now, I want you guys to understand that in R, an else statement write should come right after the if statement. If you bring the else statement in on a new line and you run this, you are going to get into an error. Why? Because there is an unexpected else on the line. So what you need to make sure that is that anytime you are typing an if an else statement, the else should follow the if statement right after that. It shouldn't be below it. This is not in Python where you can easily do that. For Python, you can just easily do your if statement, your if else, and then you are good to go without any. In Python, this is going to work. If you also change what we have here, if you have this in Python, it's going to work. If you also just bring the else statement to the down, that's also going to work. So that is one thing that you need to know. Now, another thing that you also need to take care of is that an else statement doesn't need a condition. Okay. If statement, the if, you begin with an if, it needs a conditional statement. But an else doesn't need a conditional statement. Why? Because it's just like if everything doesn't work, okay, then the thing that works next should be you. So the else is going to take care of anything that doesn't work. So if this doesn't work for you, then what remains is what I'm going to do. So that is what the else statement does. So you don't really need to provide any condition for an else statement for it to work. For instance, if we come here, we say that, okay, so let's say else val is less than val is less than, let's say, 2 print low. So if you run this one too, let's see what happens. This is also going to give us what an error. Why? Because an else statement shouldn't be followed by any conditions. Yeah, so that is about an else, an if and else statement. Please, I want you guys to take note that this is very, very important for us to be grasping the basics from here now, because when we get to we would be probably maybe next week. I don't know how far that's going to be, but I want us to probably do a project maybe by next week where we might get some data sets. We might be able to upload a data set, and then we'll be able to analyze the data sets and then generate some plots and all of those things. I just hope that next week is going to um yeah, so that's what we'll probably be doing next week. So you need to understand all of these basics, because we need this understanding of this basic is what is going to help us to be able to do what we want to do later. So that is why these things are very important for you to know them. So let's go to the if else if statement. So if then else if statement. What is this one? So if the condition, then an if else follows it. So this is what happens. Before we understand the if and then the if else statement, let's understand what a nested if statement is about. So we talk about the expression, which is we have the expression which you defined already. And then we are saying that if the expression is um, greater than 2, it should be high. Then else, now you can see that if you want to, what if you want to bring more than 3 conditions? So here you can see that we can only bring 2 conditions. So one if, then an else statement follows. But if we want to bring more than 2 conditions, so we want to print high, we want to print medium, we want to print low, how do we do that? It means that we need to use a nested if statement, meaning that in the next else, in our first else, we put another if condition into it. So if we should run this, we know that our expression was zero point 0.5, right? I'm sorry, was 3. Now, if you should now change this um, to, let's say, 5, then and run this, what do we get? You can see that we are still getting this. But let's change this. Sorry, I supposed to have changed the top one order. So I'm changing this to 5. So it means that this statement now is going to be false. So if this statement is false, then it will now come to, if the first statement is false, then it will now come to the next statement, which is the else statement. In this else statement, what we have here is that the expression is less than 1. So it means that this statement is true. So therefore, it's going to execute this code. And then what if we also now say, let this one should be 10. So let's run this. And then I said this statement is now false. So since this is now false, it means that it's not going to print this one. So it's rather going to print the last one, which is what? The low. So that is the reason why our output here is low. So this nested if statement is very cumbersome. So for us to be able to now understand how we can, the most simplest way is for us to just use an if else statement. So how does the if else statement? Please, I think I just took away something here, and then yeah, the code here. So these are some quiz, by the way. So these are some quiz that I added here. So let's look at this now. So let's take an example here. So we take this here, and then we have this. So I'm going to now take these ones out, and then we now have what an else if statement. Sorry, sorry, it's supposed to be if else statement. Um, if else. So we have our if else, and then the condition we want it to satisfy is that the expression should be less than 1 for us to say that okay, so this one we are going to print so print medium, so medium, and then we can have another if else statements here, and then we can also say um expression should be, let's say, if it is greater than, let's say, 10, we can now say that this is supposed to be what? High. Print, sorry, print low here. So um let's put our expression here. So expression here is 3. So if you run this, let's see what we have when we run this. Um, where am I getting the error? Unexpected else. Oh, um, hey, what am I doing? Error where if else statements. Expression this. Um, let me debug this and there we go. So, oh, okay. I think I'm mixing up the what's the name? I'm mixing up the if statements. Yeah, let me check that one. So if else statements. Okay, so let's debug this and then we go. So if then the yeah. So I think I am the one that is making a mistake here. Just this. Yeah. Oh God. Hey. Really? Um. What's the mistake that I'm doing? Why is it? Why is it? Why is it? If seriously? Oh my God. I'm Jesus. Guys, sorry, sorry. I think. Oh boy. And I was worrying myself. Oh, okay. So let me just change this. It's supposed to be if, else, if. Oh God. Else, if. Sorry guys, this my bad. I made a mistake here. Yeah, I don't know why I was writing if else. I thought okay, I was bringing a Python. So please, guys, sorry about that. I was bringing Python things here. Even Python, it's supposed to be together. So it's supposed to be else if, not if else, please. So that is a mistake I was doing. So let's go here. I hope you guys are following me and any questions. Please, are you guys following and you can hear me still? Can we apply this in medical data? Yes. We can apply this in the medical data. So I would try and then endeavor that the next time the project that we'll be doing, the project centered work that I'll be doing next week, I will try and bring a medical data that we can use. So probably bring a medical data where we can do the data cleaning, we can do some analysis, we can do some plotting of the data. Yeah, nice question. Ash Neha, I don't know if I pronounced your name well, but that's a very nice question though. Please, I hope you guys are still following me and if not lost me so that we move on to the next thing. Let me get your reactions, please. Are you guys there? Okay, looking forward to the yeah. It's I yeah. So yeah. Okay, yeah. There's so Neha, that's good. So yeah, I would try my best and then get some data like that and then we'll work with it. So that's what I'll try and then do the next time we meet. Okay, so good. Thank God I didn't murder your name. So let's move on to this. So here um expression. Okay, yeah, Bina says correct. So that's good. So we can move on. So here, this statement here is that okay, we want to find out if the expression is greater than 5. This statement is not true. This is false. So because of that, this is not going to run. Then the next statement is what our else if here, which is now telling us that okay, is this expression greater than 3? So like we used to do, let's unpack this. Let's unpack this here. So if we put this here, let's bring the expression is greater than first part is what? Expression is greater than 5. Then we have expression is greater than 1. Then we have expression is greater than 10. So let's see what is going to be printed out for us here. So you can see that the first one is false, so it's not going to work. The second one is true, so because of that, that is going to work. And the third one is what? Is false, so this is not going to print anything for us. So that is what will happen. Now let's look at something. Assuming that we also put this is 0.5 and then we put 0.5 here. Now you can see that the last two are all true. Let's see what happens if we put um 0.5 here and let's see what happens here. Now you can see that it is printing medium. What I want you guys to understand here is that in Python, we know that the code is executed from top to down. So even though we know that this is false, so it's going to skip this, then this is true, so it means that it is going to this is true. Then in Python, you know that if this is true, it is going to check this one also and confirm if this one is true. Mostly that is what happens in Python. But in R, as far as it meets, okay, mostly in Python too, I think if it meets the first condition, if it meets the first condition and it is true, it doesn't move on to the next one again. Yeah, so I think that happens in Python also. So here, if the first statement is true, this is let's also do this. So we put true here and then we execute this. You can see how this is printing high. Why? Because this statement is true. So the first statement is true. So it doesn't move on to the next statement, to the next statement, to the next statement. It will only move on when the first statement is false, the second statement is false, and the last statement is what's true. So if we should put 5 here, and then we should put 4 here, now you can see that the final answer is going to be low. Why? Because this is false, and then this is the only one that is true for us. So because of that, it is executing this code. So this is how the else if statement works. So that I think, please let me change this. Supposed to be if else. So this supposed to be else if those of you are following me. Then another thing is also that if else if statements should also follow themselves. So when it comes to conditions, that is if conditions in R, please they should all follow each other. So that is what they should know. There's not in Python where you can bring this one down and they can also bring this one down. Here, if you run this, see what is going to happen. You are going to get what into an error. Why? Because this is on a different line. So take note of that also. Yeah. So this is if conditions, and then this is a quiz. Now let's go to the next one, which is the for loop. So that is loop. So we are not at loops. Let me know if you guys are clear with if conditions, and if there is no questions, there's no confusions before we move on to for loops. No questions, no confusions. Okay, I appreciate if you send me the record lecture for the concept rest of the time. Please, are you in the WhatsApp group? If you're in the WhatsApp group, we have the link to the WhatsApp. We have the link to all the previous all the previous recordings. But if you are not in the WhatsApp group, you can. I don't know how you were able to join the class, but you can let me know so that I would give you um I would send the link to you so that you can use it. Now, Neha, why we are not using our studio? Um, this is just something that I chose to do. Okay, we can use our studio. We can use um, Google Colab. I use Google Colab because of the fact that I can share the notebook with you guys. Okay, so that is the reason why I use Google Colab. And then you can also use is it Proxy? Yeah, Proxy or something like that. So yeah, I know the syntax is confusing. It's almost yeah, it's almost the same. It's confusing a bit, but if you understand it from here, I think it's if you understand the concept from here, when you get to that area, it's going to be easy. So okay, the syntax is almost same, confusing a bit, would require practice, but I still don't see the values of the else in health and now, in fact, it is honestly it's very important in health. Like for instance, if you are working with gene expression data, okay, you want to be able to know there are some certain values that there are some certain threshold. Okay, there are some certain threshold values that you need to the gene values need to the expressions or the expression values need to be at for you to be able to know whether the gene is expressing itself or is the expression is low or the expression is high. So you now use this if condition to be able to give the values. For instance, a recent work that where I did was to check the length of genes, the length of genes in a particular DNA. So if we have a particular DNA, if you or a protein, yeah, I think it was a protein. So the number of genes in that particular protein will determine whether it's a functional protein or not. Mostly, some people use 20. If it has 20 genes, 20 amino acids. Sorry, that's right. If it has 20 amino acids in it, it means that it's a functional protein. So you now use and you want to probably maybe visualize the number of amino acids that you have. You want to be able to count the number of values that are in it. Then you just use an if condition. So if the length of the values in the amino acid is greater than 20, then it should append it or you should add it to the a number of lists. So that is something that is very important for you to know. It is very all these syntax are very important in R in your practice. So yeah, I understand. Yeah, sometimes it's confusing though, but sometimes with a practice, honestly, when it comes to programming, it's all about practice. Yes, practice, 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 and I'm sure you'll be able to get everything. Yeah. Please, I love your questions. Honestly, I like guys your questions. So please keep them coming, okay? Yeah. So let's go to for loop. So for loop is that this is the syntax. So for I in a sequence, we want you to repeat this. So The sequence could be a set of values, probably a list. Um, it could be a list. It could be maybe a vector. Yeah. So here, this is an example. We have a gene. We have this vector called genes, and then we want to be able to count the you can count the number of genes that are in it, or you want to say, okay, you are analyzing this gene. So that is what we have here. So for gene in genes, so for some people will use I, so you can use I here in a variable I thought that you have. So for I in genes, print or paste. I don't know if you've come across paste here, but paste is mostly used when you want to concatenate, um, you want to do concatenation. So here we are having these uh, character strings here, and then we want to concatenate our results here to that. So we use the paste to be able to do that. So you can see that it is going to go through this vector and then append the values in this vector to this print statement. So that is what it's doing. So it goes to here. So it comes here, takes this value, and then put it here. So it comes here, take this value. So here, this I here is this. So this I here is this. So this I here is this. So this I now becomes a variable that can now be put into this. So it will do this until the number of values in the gene is finished. So that is mostly what the for loop is used to do. Now, we can use these to count the number of values. We can use these to, for instance, if you want to, like I was telling you guys that um, about this thing, the work I did, you can do something like this and then count the number of genes or the number of amino acids that are in the gene. Let's say you have a gene of sequence. Um, let's say we have gene and then A, so A T T A C G C T C A, yeah, so something like this. And then you want to be able to count the number of values, the number of A's, the number of C's, and all of those things. So you just go straight. So for I in genes, in the values in the genes, then you tell it to count the number of genes the number of A's that are there, number of T's that are there. All of these things are very important for you guys to take note of, because we'll be I wouldn't want us to really go deep into this, but when we get to, I'll try my best so that next time, the project that we'll do, maybe we'll do something on this, or maybe you guys can suggest some medical data set that we can use so that we can maybe probably do something, some interesting projects. Yeah, then. So that is just by the way, and then we have some quiz questions here. So write a for loop to print each element in A, T, C, G. Yeah, so these are some videos and then some um, things that you can do here. Now let's look at the next one, which is what the while loop. So a while loop, the difference between a for loop and a while loop is that for for loop, you mostly know the number of things that are inside your um that you want to go through. You know that the number of values that you want to go through. So for instance, in this for loop, there were just three items. Okay, please can you please go over the for loop again briefly? Okay, great. Yeah, so let me do that. So I'm saying that with for loop, you have um, I in a sequence. So for items, so mostly I stand for items. For items in a given sequence, we want you to do something. We want you to be able to repeat something. So repeat this until all the items in that sequence are done. So we have genes. And then these are the items that are in this gene. So this is the sequence. So this is our sequence. So the genes here is our sequence here. Now for I, which is the item in these genes, we want you to print that, okay, we are analyzing this I. That is, we are analyzing the value here. So this I here is this, it's also this, it's also that. So first, the loop will come to, will go into this, and then it will meet this, and it will assign this value to I, and then it will do what we ask it to do here. So what we ask it to do is to what? Paste or print, analyzing um, gene, that is the value. So this I here is assigned this value. Then when that happens, it turns out the values inside here are not done. So we still have this. So it will now come to the second value again and then do the same thing. Come to the third value again and then do the same thing until the number, assuming we are having 1,000 values, it will do that same thing. So analyzing this, analyzing that. Yeah, so that is what this is doing for us. So that is how a for loop works. So I don't know if that is clear enough, Teresa, for you. Is it good enough, Teresa, so that we move on? Okay, great. Thank you. Thank you T, so much. So the next thing is what? While loop. So I was saying that the difference between for loop and while loop is that for loop, you need to be able to know how many, for loop, you know the number of items that are inside your sequence. Okay, but in a case where you don't know the number of items that are inside your sequence, what you do is that you use what? A while loop. So while the condition is true, sorry, while this condition is true, is false, sorry, not true. You want it to I'm sorry, it's true. Hey. While this condition is true, you want it to repeat this thing until this condition here becomes what? False. So that is the syntax. So a while loop will keep running as far as the condition is true. So this is something that I want you guys to understand. Now, you often use this, like I said from the beginning, when you don't know how many times you need to repeat something. So here we don't know. Here in the for loop, you know the number of times. We know that we have 3 items. So go the number of items that you have. But here, you'd use it when you don't know the number of items, the number of times you want to repeat the thing. So, for instance, if you want to reach a certain threshold for a gene expression, you use a while loop. So, while this condition, until this value is met, this threshold for the gene expression is met, keep running. Or you want to be able to scan through a pattern to be able to find something. So like you have a gene sequence, you want to be able to move through that gene sequence till you see a stop codon. Stop codon is mostly represented by an asterisk. So till you meet a stop codon, then you use what? A while loop. Because if you are using a for loop, you can use a for loop though, but for you don't know how long the loop is going to go until it meets the number of amino acids are going to go until you meet a stop codon. So you make sure that you use what? A while loop. So that is mostly how we use while loop. So here we have our condition. We have a this value that we have, this expression value, which we have assigned it to 1.2. And then while this value here is less than 5, okay, is less than what? 5. What we want to do is that we want to print the current gene expression, and then we now want to do an increment. So in while loop, you need to make sure that you give the statement and then what you want to happen. Okay, so we want it to be able to print what? The expression. But then after the print expression, we want to be adding particular value to our value until we are able to get to where we want. We are able to get to the particular threshold that we give. So um, while our expression here is less than this threshold that we gave, which is 5, we want it to that, okay, print current expression is then the expression value. And then what is the expression value we want to print? We want to print this expression value first, and then keep going until you hit 5. So if you don't hit 5, it will keep going. So here we are doing this. So you can see that it will go, go, go. So it will just be adding 0.8 to this. So 0.8 to this is going to give us 2 point 0.8 to this to give us what, 2.8. Then until we get to 4.4. 4.4 plus 0.8 is going to be more than 5. So you can see that it stops here. If we put 15 here, it will continue until it reaches a value that is less than 15. So you can say that this is how while loops work. So we don't know how long we are going to go. So you make sure that you give it what you want it to present to you, and then you need to make sure that you give it an expression that it needs to be following. If you don't give this expression, I don't want us to maybe like end in if I start right now, this runtime is going to break, because if I don't bring this condition here right now and then I run this cell, in fact it should just be going because the expression is going to be true until. So okay, let's try this mostly and then see what is going to happen. You can see that it is running, it will continue running. This has gone into an infinite loop until we stop this. So if you don't tell it, if you don't give it a condition for it to follow, if you don't give it this operation for it to be doing, it's going to continue, it's just going to be into an infinite loop. So this is what while loops can be used for and what we can do. So you can see that here this will stop at when it hits or exceeds 5, which I just illustrated to you guys. Now um for us to be able to understand, I told you guys that here, okay, here when we check, you can see that our while loop has entered into an infinite loop. But how do you break out of that loop? So how do you escape from that loop? Use a break statement. So a break statement is used when you want to terminate the loop early, even if the condition is still true. So we have this condition here. So we with our gene expression value here, and then we have a sample ID which we are assigning it to 1. So while our expression is less than 10, we want to print the sample ID. So sample ID 1 and then the expression value. But then we want to make sure that if the expression gets to less than 5, we want to add a break to it. Because if you don't bring this break to it, if you don't bring this break, what will happen is that it will keep running, 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 just like I illustrated here where we entered into an infinite loop. It will just be running until you hit the stop, the stop. So we want to be able to, this is even than under the example that I gave earlier, that we want the while loop to continue going until we meet a stop codon. So this is what you do. So you define your stop codon here. Maybe you use asterisk to define your stop codon. And then while the expression is not a stop codon, you want it to keep appending some values, or you want it to keep reading the genes for you. So that is mostly what this does. So here you can see that we have what we are doing here is that while this expression is less than 10, we want it to print the sample, which is the sample ID, and then the expression value. And then while it is, if this expression is still is greater than 5, if this expression that we have here is when it gets to more than 5, what we'll do is that we want to break out of what the loop and say that okay, expression is too high, so stop early. So we want to break out of the loop here. And then always note that every while loop should have what this operation. So it needs you need to give it the condition, the operation for it to continue following until it gets the end. So we want to keep adding one to the expression value. We also want to keep adding one to the sample ID. So this, if you run this, you start, we have sample one, the expression value is this, sample two, the expression value is that, sample three. And then when it gets to sample five, because now expression value has gotten to five and it is going to be greater than five. So since it's going to be greater than five, it will now break out of the loop for us because it has now hit this code. So this is how we use a break in a while loop. Then we can also use the next to probably skip some values. So for instance, here in this gene, we have this gene's name, but then we have NA value. This NA value means what? Not a value, so no value. So we want to be able to skip this, want it to continue moving even after it. If it meets this, you should just skip it. So that is what you want it to do. So the same thing while I we now we are assigning the length of our the length of the gene. The length of the gene is 4. So 1, 2, there is 2 here, 3, 4, and then what, 5. So this is going to give us okay, let's just unpack this. Let's unpack this so that we understand this here. Okay, so we unpack this, and then let's say we want to print the length of this. I think we met length already. I don't know how many, if you guys remember this, but the length is given as 5 because we have 1, 2, 3, 4, 5. So there are 5 items. So while I we are now assigning this I to the length of that value. And then the number of genes that we have, we are now assigning 5 to the genes. So these genes here is now taking these I values. All we want to do is to be able to iterate through the values in the gene. So that is what we are doing here. Now, you now skip if there is what, an empty value, or the value is missing. So if it is NA, we met this thing last time. I don't know if you guys remember this, but I showed you guys that this is an OR statement. We have 1. If you bring just 1, so let me show you guys this. So um this, oh sorry, let's bring our gene. Okay, so genes or where's my, okay, so genes or this, oh wait, let's I'm trying to get an example here. But okay, yeah, let's move on. I'll get the example maybe later, but let's hold on to that one for now. So this double sign, this double what is the name of this? I'm forgetting the name of this straight. This is not okay, I think I've forgotten the name of this. Seriously. So the double one means that it will come, and then this is called or in Python, in R. So what it will do is that it will check this, if this information is true or this information is also true, then what it will do is that it will execute this for us. If this information is true and this information is false, it will still execute this for us, because false or true or false, it is still true. and then true and true will only give us true. True and false will always be false. So we use this to tell it that okay, if it should meet this or it should meet this, what it should do is that it should skip this. So it should go to the next thing. So that is what we are doing here. So it will now go to the next thing. What's the next thing? The next thing is that it's supposed to print this for us. So analyzing the gene, and then what gene is he analyzing? It will now append these genes for us. So we now have this condition, which I always tell you guys that you need to use it in your while loop. So that is what is happening here. I hope I'm still, yes, I'm still with you guys. Okay, so here you can see that in the output, it is omitting this empty string here. It is also omitting this NA value here, and it is only appending the gene values for us. So this is what we have. Okay, so let's get back to this the gene that I was the thing I was talking about. So let's say we have this gene. Okay, so let's say we have a gene and then we assign this to it um, TP53 and then okay gene 1 and gene 2 we assign BRCA1. Okay, so if you say gene 1 or gene, I hope this thing work too because what are we doing here? Okay. This and this trace back operation is possible for only numeric. Oh, okay. So 2 and 3. This give us true. Yes. So let's use the numbers here. So this is going to give us true. Why? Because one this is 2 or 4 is just going to give us it. Here we are not really doing anything though. We are not doing any operation. So let me give you guys okay, let me give you guys some more elaborate examples. Let's say we have this and then we have 1 to let's say 5, okay, and then we check this out. What do we get? So here you see that um this is telling us that one or four, one or four. This is gene one. In gene one, it has one. So it will now come and compare 1 to 4. If it compares 1, so gene 1 is 1, which is true. Gene 2 is 4, which is also true. So this is going to give us true out. But then if we bring 2 of these bars here and then we run this, what will happen is that gene 1, gene 2 length is okay. So this one has has more than 4. So yeah, this is going to give us true. I think I need to get some more elaborate example to give you guys this. But let's just hold on to this. So this is what I want you guys to understand. I'll get some more elaborate example and then we will use as we go. So this is we got this part already. Now when do you use a while loop? You the end condition mostly isn't based on mostly a fixed repetition, but mostly you need to understand the dynamics of the values that you are going to be using. So for instance, you need a continuous check. If you need a continuous check on a biological threshold, you need to make sure that you get a convergence condition or mostly a user input to be able to determine the when the loop should stop going. But please don't use don't use a while loop when you already know the number of iterations. So like I said, use a for loop instead. And then don't also forget to update your loop, because it can lead to an infinite loop, which I showed you guys also. So here, this is the update condition. So this is, you are always updating your condition as it moves on. So here we are updating our condition, our loop, as it moves on. So we are updating our loop here, because if you don't use this update condition, the loop will enter into an infinite loop. So that is what we talked about. So these are while loops. And then before we call it a day, let's talk about functions. But before we get to functions, please let me know if you guys are still following, or you have confusions, questions, or anything. Okay, some questions in the chat. Okay, can it be like we upload or attach a file like Excel and then use the code you just wrote? It will automatically read the data from the Excel file and create a visualization approach for the expression level, because I think if we do some kind of expression analysis, the data is already created by the SC. Correct me. Okay. So the your question is very interesting, and then the thing is that in an Excel, maybe you have a CSV file, okay? So you get a CSV file into, you upload a CSV file, maybe using read CSV or any of the functions that we use to read CSV files. Now, mostly you are going to have in your um in the columns. So probably you have some values in the columns, and then um maybe you want to group the values in that, or you want to group the data set, the values in your data set, to be able to have maybe um, for us to be able to know that, okay, if the value in a particular column is greater than a given threshold, okay, we want it to give us, we want to say that, okay, um, the gene is being expressed more, or the gene is being expressed less. So that is mostly how the thing is going to be. It's not like you are going to now write that logic to be able to get, for instance, I think you can even use this to create maybe a column, maybe um, yeah, expression value, or expressed, or maybe um, expression condition, or whatever it is, called a new column that you want to create. So then you go back to the expression value. Maybe you have a column called expression values. Now you want to use that expression values to be able to create a new column, to be able to tell whether the gene has been highly expressed, or maybe is low, is the expression is low. So you now use this condition to be able to create that new column. So like I said, maybe when we start doing like some more practical examples, so this might make sense then. Yeah. Now, Teresa, you said the next part isn't clear. Is it the while loop, the for loop? Let me know so that I go back again and then explain it for you. Please let me know which part is not clear so that I know where to start from for you. The use of next. Oh, okay, 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 great. So the use of next. So let's come here. Do I have next here? So here. So what I'm saying here is that we have this gene. Um sorry, this what's the name? This gene here, this vector. Yeah. And then in this vector we have this gene name. This is also an empty string. This is also a gene name. This is also an NA value in R, means what? Not a value. Not that is not a value. So this is an NA value. Mostly when you are doing data cleaning, you might probably clean this one out, or maybe replace it with some values. Then this is another gene. So you can say that in this vector, we have this gene, and then that gene. But we have other values in the gene in this vector that are not gene values. So this is an empty value, this is an NA value. So what we are saying here is that we want to go through this gene vector here. So while we are going through each of the values, while we are going through this value, this value, this value, this value, that value, what we want to do is that if we meet any any NA value, which is this value, or we meet an empty string, what it should do is that it should skip that. So let me come to this place. And then let me see if I can clean this. Um, yeah, so let's clean this. So we have our gene, okay? So genes here, and then this gene is assigned these values, which are, let me just say T1, and then we have an empty string, and then we have let's say A2, and then we have an NA value. Let's say we have P1 or P3. Okay, so we have these values in this gene. So what the next keyword does is that in our while loop, where we put this next, what we are telling it to do is that we want the while loop to now go through all of these values. And then if it should meet any empty string in this gene variable that we define, or it should meet any NA value, in this vector that we define, it should just skip that. So that is what the next keyword is doing. So it should just skip that those values, and it shouldn't do anything. It shouldn't print them. So that is what we are telling that is what the next function or the next keyword is telling the while loop to do. So that is what is happening here. So the loop will start from here. Okay, so here this is not an empty string. So this whole thing here is false. So it's not going to execute what is inside here. So it's now going to come to this place and then execute what is here. So it will tell you that, okay, we said we gave the gene here, so it will we are assigning this gene to these values here. So like we did in the if in the for loop, where we said that we giving I, so this I is now assigned this value. So that is what the gene is being done is assigned to here. So we have this gene now that we have assigned it the values in here, and then it meets this, which is not an empty string or an NA value. So it will print it out. But then it comes to the next part, and then you can say that next part is true here, because if there is an NA value in it, so it meets this NA value, or it meets what a gene inside this gene, which is what empty, so which is an empty string. What it's doing is that it should go next, meaning that it comes here, meet this, no, don't do this, go next. So it will now skip this and then go to the next value. It meets this, which is NA value, which makes this condition true. So it will now also go next. So it will not print this, it will now go next. So that is mostly what the next um, keyword is used to do. I hope that makes sense to you or for you, Teresa. Let me know if it makes sense so that we move on. Yeah, thank you. Thank you so much for that. Okay, so we now move on to functions. So functions, um, we are not, we would be Mostly, okay, yeah. Sometimes you define your own functions very well. So, um, when we get to that aspect, we talk more about things like that. But here, I just want you guys to get an overview of what functions are. So, you give the syntax that you give the function name, and then you use the function keyword. So we use the function keyword to be able to um we use the function keyword. Okay, yeah, Neha, you are asking your hand is up. Oh, okay. Okay, so let's move on. I thought I saw your hand up. So let's move on to the function. So we use the function keyword to define the function. And then inside the function, we have what we call arguments. So argument one, argument two. Argument two is equal to default. I would explain this when we get to default arguments here. So the name of the function is greet, so we give this the name of the function, and then we use the function keyword, and then the name here is the argument. The argument is what is the value we provide to the function. You There are some functions that don't require argument, but there are some functions that you need to give it an argument. For instance, if I give it an argument, then it means that I would I should make sure that I provide all the details I want. So hello, Alice here, and then I can just run this function and then it will work for me. So what the function argument does is that the argument is used to set the value we want the user to be able to enter, or you to be able to enter into the function. So that is what a function argument is about. Now, this function argument could be, I'm sorry, this function argument could be um, default, or it could be required. For instance, here, if I don't bring any value here and I just run this greet function, what happens is that it's telling us that it is missing what? Um, there's a name argument that it is missing that I need to provide. So you need to provide it a name, and that name is a string. So you give it what? The name, a name, or let's say, yeah, so Alice or Gamma here, and then you run this and it works. So um, now the default argument has to talk about the fact that anytime you create a function and you give it a value, you give the argument a value, that becomes a default argument. So for instance, if this name here, I bring gamma here, so I bring gamma here, and then I don't bring anything here, this will still run. Why? Because I have given this function, this argument, a default value. Now, default values can also be overwritten. So let me change this to Neha here. And then you can see that what will happen is that it will now change this default argument value we gave it here to the name that we provided to it. You can also put Theresa here, and then this is going to run. So this is how what a default argument is, and then what um, um, and the argument that we need to make sure that we provide that argument. So here, if we get back to this place, just like we did here, we are not providing a name. So here we have the name we provide to it. Like I said, if you don't um, assign any name here, what is going to tell is that there is what? A missing value, because this function is not having any what? Any default value. And this is a constant, a value that is an argument that is needed. So that is something that you need to take note of. So this is we define um, how we define functions. Um, Mostly will be you might define your own function. Maybe you are working on a data, and then you want to visualize maybe some numeric variables. But then yes, you can't be repeating the code. So the reason why we mostly use function is because you want to prevent repeating ourselves. So instead of you repeating one code for everything, what you decide to do is just create a function for it, and then you now use the values you are now going to use. Maybe the columns you now be using, you now use them as the keyword argument for the function. So here we have a function, and then we have x as a keyword argument, and then we have y as what, a default argument. So if we do here just 4, this is going to mean that we are the x is what, is 4. So 4 times the 2 here is going to give us 8. If we now change this, if we bring comma here and then we bring 6 here, what will happen is that you can say that 4 times 6 is going to give us what, 28, because this 6 is overwriting this function here. Now another thing is that you can also decide to write the function name, the argument name, assign the argument name automatic. You can write the argument name and then assign the values to it. So for instance, this can be x is equal to 4, and then this can be y is equal to 6, and then this also works out. So either you bring and this is very important because there are sometimes, um let's say I have z here, okay, which is also an argument, and then this is we are now adding the z to it, and then you write here. Now we know that x is um a, an argument that is needed, y is a default argument, but z is also an argument that is needed. But just put 4 and then 3 here. Let's see what happens here. You would see that this is going to give us an error. Why? Because it is missing a z argument. Why? Because um, the positions, the values, the arguments that are here are 3. So there is no positions. The values that we've given are just 2. So it doesn't know which of these values is you assign the 4 to, whether it should assign the maybe the first one it can assign the 4 to this x, yes. But now this 3, it doesn't know whether it should assign it to this y or to this z, even though y is what, is a default argument. So this is also something that we need to take note of when it comes to default arguments. So this is the reason why mostly when you are defining your functions, the best practices is to always put your default argument at the end. So let's say we now change this, y is constant, and then we now make x to be 2 or 3 here, and then we change this and we run this. Let's see what happens when we run this. Now, okay, um, yeah, okay, we are still on. So here you would see that this is working because the last value, which is the z, is what, a default argument. So mostly the best practices is to always put your default argument at the end of your function. So this is that, and these are some questions here and some bonuses. These are some default what's the name, default functions that you can use: mean, median, max, length, string, and all the rest. And then if you want to get help in R, you use this. So you want to get help for mean, you use question mark then mean, or you can just type help and then the name of the function that you want to get help with, and then it's going to give you this information. In R, mostly it's going to give you, if you are using R Studio, it's going to give you some nice write-ups. But in Google Colab is, these are some gibberish things that is, but this is just reference. So reference, you can just go through and then you read through it. So this is how you get help in R. And then some jokes. So there's these resources that I shared with you guys. This is on Data Camp, so you can check these resources out from Data Camp. So this is all for today's class, and I'm here for questions. Let me know if you guys have questions. If you guys have anything that we should talk about before we call it a day. Yeah. Now question time, guys. If there are no questions, then I presume all of us are okay, and then um we can close today's class, and then I would make the recordings available. Yeah. So any questions? Oh, we are okay. Okay. So I think they always say no questions. Okay. Thank you so much, Teresa, and thank you all of you. Oh, okay. So no questions. Thank you so much, Teresa, for the response, and thank you guys all for your time and everything. I would make the recording. We'll make the recordings available on the YouTube page for you guys to go through it again. And as usual, if you have any questions, any confusions, you can still hit us up in the on the WhatsApp page, and then yeah. So that is it for today. Thank you guys all for coming, and we'll catch up another time. Let's see what happens next week. Probably maybe we take one data set and then we analyze it and then get some insight from it. So thank you all. Good night, and have a nice sound sleep. Bye bye.